Hello students. Today we are discussing the next one, a new topic, that is silicon controlled rectifier, that is SCR. So now silicon controlled rectifier is also an electronic device. Normally this is called as a thyristor. How this device is working, and again the structure of this and VI characteristics of this, all the things we will discuss. So now first of all we'll move to the structure and the symbol of the silicon controlled rectifier. You are observing here, I'm showing you, this is structure. You can see the structure of the SCR, and this is the symbol of the SCR. So now what you are seeing here, the silicon controlled rectifier is having three junctions. So what are the three junctions? Where are those? So now see, this is the first junction, this is second junction, and this is the third junction. You may ask me, sir, if it is having a three junctions, then how many layers it is having? So obviously, if you are observing here, if it is having a three junctions, then it is having a 1, 2, 3, and 4 layers. So what are those 4 layers? It is P layer, N layer, P layer, N layer. So number of layers are how much? There are total 4 layers, and these layers are creating 3 junctions. Now when PN junction is normally, how it is going to be operate, how the flow of the current is going to be happens, it is going to occur in this device, everything we are going to be see. So now for these layers we are going to make a connections, lead connections. So we need obviously the terminals to give a voltage supply and check the current. So where you are going to make these terminal connections? So you can observe at the top side of the structure, here there is a one lead connection made to the P layer. So that is called as a anode. So it is mentioned with the A symbol in the bracket, you can observe here. And at the below you can see there is another one lead connection to the N layer, that is called as a cathode. So it is mentioned as a K. And third one, again one another connection made to the P layer, this is called as a gate. So 3 terminals are taken, one from the P type of material called anode, second terminal from the below you can see, that is N type material, it is called as a cathode, it is made the connection, and third one from the again P type of the material, it is called as a gate. So what happens in the normal operating condition of SCR, anode is always try to keep, or it is held at a high positive potential with respect to the cathode. So what we are doing, we are giving a supply to the anode and cathode, where we are maintaining the positive supply has to be given to the anode, and the negative supply has to be given to the cathode. So again the gate and this third terminal has to be maintained small positive potential with respect to the cathode. So what is the third terminal, what we have to maintain? A very small amount of the positive potential with respect to cathode. So this is whatever the thing we have to be maintain to observe the operation of the silicon controlled rectifier. So now next we will move to the working principle of the SCR. Now I'll explain the working principle of SCR. So now before going to see this working principle of SCR, I just want to clear one thing. In a silicon controlled rectifier, the load is connected in series with anode. So always remember, the load is connected in series with the anode. The anode is always positive potential with respect to the cathode. So already we have discussed this. So here, which one is a anode and which one is a cathode? Here there is an anode and there is a cathode. So in between these two terminals, so we are applying a positive supply, where this is a positive and this is a negative voltage we are given. So it is maintained. So anode is connected with the positive and cathode is connected with the negative. But one load is RL is connected in series with the positive supply to the anode. So always we have to connect it. And the next, the working of SCR is based on two conditions. So what are those two conditions, how the working of the SCR is going to take in place? So first one, just I want to clear. So when there is no gate voltage is applied, when there is no gate voltage is applied, you can see over here, this is a one connection I have made. So this is called as a gate terminal. To the gate terminal there is a connection, and these two connections are not made with any potential supply. So now it is open. So gate is open now. This is called as when no gate voltage is applied. So what happens, how you are going to observe the conduction of the current through the SCR when this is no gate voltage is applied. So second one, when the gate voltage is positive with respect to the cathode. So in the second operation, what we are doing, we are going to observe when the gate voltage is applied. Before that, we will go to this one first. So this is called as when no gate voltage is applied. So how this is going to be work? So the working principle of a SCR when no gate voltage is applied, it is diagram has to be this, you have to draw if it is asked in the examination. So what happens under this condition? So already one voltage is applied to the anode and cathode, and another voltage which is not applied to the gate and cathode. Under this condition, so what happens, the junction J2, so here J2 is mentioned here. The junction J2 is reverse biased, while remaining junctions J1 and J3 are forward biased. So at the center, what you are having, this one, it is called as a J2, it is reverse biased, and J1 and J3 are forward biased. So hence the situation in the junction J1 and J3 is just as in NPN transistor. So with the base being open. So what we can say, when base is not connected to the NPN transistor, and this type of NPN transistor, how it works like that, here only it is going to be work. So what happens if J2 is not forward biased? So there will be no current flows through the load to the that is a RL. So if obviously J2 is not conducting, that is not forward bias, means it is reverse bias. Reverse bias means there is no flow of the current from in this direction. So obviously it is not moving from anode to cathode because J2 is a reverse bias. So what we can say, the SCR is in cutoff mode, it is in switched off, there is no on. However, if the voltage, if you are going to increase, so this voltage if you are going to increase gradually, so what happens, the stage is reached when the reverse bias junction J2 breaks down. So obviously when it is acting as a reverse bias, and you are gradually increasing the voltage to the anode and cathode continuously and slowly. So obviously at the some time J2 will break down. Now what happens, the SCR conducts heavily because already J1 and J2 are forward biased, and if the junction J2 will be breaks down, then current is suddenly start conducting. So now you can say SCR is it is turned on. So this is a method how you can make the SCR turn on. So when no gate voltage is applied, but what happens here, the voltage which you are applied to the anode and cathode, you have to increase and increase, because after applying a small amount of the voltage it will not conduct because you are not using a gate voltage. So remember, so in this mode it requires maximum voltage to make SCR turn on. So next we are going to see the second, when gate voltage is positive with respect to the cathode, what happens. Now this is a next one, that is a second, when gate voltage is positive with respect to the cathode, what we have did the changes here. So you are we have did this. I will show you. This is a positive supply I have given to the gate supply, to the gate terminal. So here gate and this is a cathode. These two terminals are made positive potential with respect to the gate to the cathode. Gate is a positive, cathode is a negative. Now what happens? Previously we have seen that there are the three junctions, that is a here you can see this is a junction J1, this is J2, and this is J3. So now in this what happens, J1, J2, J3. So first the voltage, when the gate voltage is positive with respect to cathode, under this condition J3 is a forward biased and J2 is a reverse biased. What happens, this is a J3, so this is a J3. So here we are applying a positive supply gate and the negative to the cathode. Obviously this is Pn, this is P and this is N. So these Pn layers are acting as a forward bias. So these acting as a forward bias. So if they are acting as a forward bias, J3 is also, it is acts as a forward bias. So now J2, this is obviously it is acting as a reverse bias. So the electrons from the n-type material starts moving across J3 towards upper direction. When you are applying the gate supply, the electrons from the n-type material here, so they will start moving towards to the this side, left side. So when the electron starts moving to the left side, so obviously when the holes from the p-type, whatever the holes we can say, they are trying to move towards the right side. So this is called as there is a consequently the electrons from the junction are attracted and the holes are going to be moved towards the right side cathode. There is a heavy current starts flowing. So obviously some of the electrons from the n-type material, they will move towards the J2 junction. So already J2 is a reverse bias, but electrons are moving to the J2. As soon as when this gate current starts flowing, so obviously when this is p-n junctions are acting as a forward bias, immediately the current will slowly starts conducting, gate current also starts flowing. So as soon as gate current starts flowing, what happens, anode current increases. The increased anode current in turns makes more electrons available at junction J2. So at the junction J2 there will be more electrons. So this process continues, and in an extremely small time junction J2 breaks down and the SCR starts conducting heavily. So what we have made here, we are applied the gate voltage. Because of the gate voltage, the PN junction becomes the forward bias, and if it becomes the forward bias, small amount of the gate current starts flowing, and as soon as gate current starts flowing, the number of electrons starts collecting towards the J2 and the anode current start increasing. So if the anode current starts increasing, within a fraction of a second, J2, which was previously as a reverse bias, it will immediately breaks. So if it breaks, then we can say SCR starts conducting, or it is in a on condition. So this is a making the SCR turn on by using the gate supply. So after doing this, even if gate voltage is removed, the anode current does not decrease at all. So once it is start conducting, then remove the gate voltage, then the gate voltage is not having any control over the flow of the current from the anode to current. The only way to stop conduction is to reduce the applied voltage. So reduce the applied voltage, that is called as a break over voltage, that is minimum voltage which is required to turn on the SCR. Without gate voltage, previous diagram, no gate voltage is applied. At that time you are increased the anode cathode voltage. So at some particular time it will break the junction J2. So that minimum break over voltage, if you are going to reduce it below, then your SCR will be turned off. This is a working procedure of the SCR.